Okay, good morning. A quick little introduction on myself. I'm a principal consulting engineer for Nokia's IP and Optical Networking division. My focus is on network automation and SDN controller solutions. All right. Quick little background on myself. I've gone through an evolution, right? I mean, I think that word gets abused and used quite a bit in a lot of these discussions, but I started in the industry about 20 years ago. Okay, and so over those 20 years, I started on fixed access portfolio, all right, SONET, digital loop carriers, ATM, then transitioned over time to IP type of networking infrastructure, eventually into network management, assurance capabilities, and now into obviously a lot of this automation capabilities, right, which is another word that gets abused quite a bit. Right, but a lot of the automation as well as the optimization capabilities. Now, my intent for this presentation is not to discuss necessarily collapsing of these domains, right, into one physical domain or getting into any type of specific optics integration discussion. My intent is more around the value of centralized type of hierarchical controllers, right, or software, leveraging or providing the awareness, of course, across these different layer domains. Right, providing obviously the linkage between these domains, the infrastructure, awareness across the infrastructure, awareness, of course, of the reliability of each of these domains, and leveraging all of that to build service infrastructure, right, across that still meets the performance demand, right, especially performance demand that's going to be becoming higher and higher, right, as we look at these next generation of application flows that are coming in. Okay. So, taking a little bit of a page off the book of Bakash's keynote presentation yesterday, if you were there, he mentioned some key requirements, right, as cloud, IoT, and 5G and the horizon are going to be impacting this, right? And to be honest, these requirements aren't brand new in the industry. These requirements have always been there, right? But he talked about the massive scalability, right? What has changed is obviously the demand, the speed of the demand has increased on capacity. He talked about the horizontal growth capability that you need to maintain, right? To quickly deliver the, obviously, platform in a timely manner, deliver the service, of course, all right, deliver the capacity, right, for faster capacity growth. He also talked about the capability of, obviously, right, again, it's nothing new, but the reliability aspect of it, right? That still hasn't changed. You still need to provide a performance across that infrastructure, provide obviously reliability, right, across these different layers, right, as well as the security to maintain, again, that performance intent for the service. And then lastly, obviously where there's been quite a bit of an evolution is on the automation side, as I said, right? Whether it's abstraction of the APIs, whether it's defining, obviously, configuration workflows, defining, of course, event-driven workflows, defining that intent for that particular service and that particular infrastructure, and how do we maintain that infrastructure moving forward, right? Maintain that infrastructure relevant to the service. Okay? So I'm not telling you anything new here, right? I'm not showing you anything new in this particular slide. I think everyone is well aware of, obviously, when looking at these different layers, we all understand that the underlay, whatever that underlay is, right, has an impact on that particular overlay infrastructure, right? It obviously has an impact to the service itself, has an impact to the performance, okay? But what's missing here is awareness of the infrastructure above and awareness of the infrastructure below, right? The correlation isn't there today. So I'm highlighting a few things here, right? Some basic questions that have come up over the years in trying to understand all of this, right? So for instance, is there a more optimal performance route for services? All right. So today, obviously, when you're looking at the layer, the IP layer, it's next hop, right? But what's not being looked at is obviously that optical infrastructure, right? That particular IP path, that one hop could be taking a longer path than what you expected, right? As a result, an impact on latency. Okay. So how are we understanding that we're taking the most optimal path for a particular service infrastructure? Okay. Now, the other part that comes up often, it's just not about automation, right? There's also a post side of the house. It basically, how do I troubleshoot, right? How do I obviously narrow down or decrease that time to identify the impact of the service. This is going to become important, obviously, in the long term from a closed loop type of capability, right? But alarm correlation. Alarm correlation is always important. You need to have that awareness of all this infrastructure. How do you know that a particular optical service, the performance on that optical service, is what's actually impacting that MPLS path, right? How do you then identify that and then basically address it? The other part there, sorry, I went ahead a little bit, but are these services on a diverse path? Okay, so when you look at these primary and secondary service infrastructures, we want to ensure disjointness, diversity, right? We don't want to identify or leverage a particular link or an infrastructure that if there's an impact to it, it's going to impact both my primary and secondary. Again, nothing new, but what's been missing is obviously that awareness of the optical services underneath. Last but not least, all right, what services, again, kind of going to that awareness standpoint, right? What IP services are leveraging that particular lambda or that particular optical link? Okay. Now, I think most of you may know this, maybe not, but in the great words of G.I. Joe, I think everybody understands knowing is half the battle, right? So again, it's awareness, understanding what infrastructure is there on that particular optical infrastructure, what IP services, what is the MPLS infrastructure that's leveraging that, in case I need to take some kind of maintenance, proactive or reactive type of capability across that, right? Or some what-if predictive analysis across that, right? What are the optical services? If I make a particular event or maintenance window and I address a particular link, what am I going to be impacting? I need to have that. Do I need to then move that traffic if possible? All right. So one of the use cases that's there on the horizon that's going to be impacting all of this from a transport point of view is 5G network slicing, right? Why? Right. If you look at obviously this network slicing, what does that mean? It's basically stitching of resources across different segments. Okay, sounds simple, but when you look at this, right? When you look at obviously this resource allocations for these use cases, right? You have obviously in general 3 different domains to simplify it. You've got a RAN infrastructure, you've got a core, packet core infrastructure, and then interconnecting all of this is obviously these transport interconnectivity services, okay? But when you look a little bit further to that, then there's disaggregation at the RAN, right? So now you're breaking that RAN component further, right? You're virtualizing it. You're introducing more front haul, mid haul, back haul transport services in between that, right? You still need to maintain performance. You have data center interconnectivity that you've got to keep in mind within that disaggregated RAN. Right, and looking at the core, same thing. Obviously, you've got data center interconnectivity within that data center or packet core that you've got to maintain. Right, and there's, depending on the use case, your peering points, the services, the different customers, there's a high level of obviously service infrastructure that's going to get created. So you've got to maintain that. There's obviously performance requirements across all of that infrastructure. Right, so you have this high scale transport infrastructure that's being built out. You've got high requirements on obviously the performance of each of those infrastructures. Now, we've sliced and diced transport services in the past, right? This is nothing new. But now when you look at it, right, as I mentioned, all of those different segments, right, whether it's obviously VXLAN, segment routing within the data center, the BGP type of segment routing capabilities that are there, right? Your hard slicing with photonics, right? So looking at the different data centers that you're going to interconnect with depending on your cloud exchange connect, right? Your edge data centers, which have that disaggregated RAN, right? So you've got a higher complexity there that you need a type of transport control capability, right? And just another thing to keep in mind, right? As 3GPP is, focused on obviously this RAN and this core slicing and trying to stitch all of this. What's been lacking, to be honest, is that transport slice, standardizing on that, right? Because at the end of the day, regardless of who the vendor is underneath, there needs to be a level of abstraction, right? As I mentioned, automation is an important key, okay? So this is going to be obviously one case on the horizon that's going to have a big driver from an IP optical transport capability. Now, over those recent years, obviously there's been evolution at the device level, right? So we're all well aware of a lot of the capabilities that have been introduced, right? From segment routing to drive that, again, high scale capacity, scalability, light configuration, right, across BGP, IGP infrastructures. CDCF, right, to provide wavelength switching or routing, right? From a control plane, more further restoration capabilities with GMPLS, right? So again, more capabilities at the actual quas functionality and looking at deterministic quas and looking at the minimum resources to deliver those particular services, right? Further traffic engineering, right, with capabilities like PSEP and being able to look at holistically across a particular service or a particular path end to end, right? And with that, right, and a lot of this capability, you need the programmable interfaces, right? You need the data mining capabilities. So there's been an evolution there, right? We've gone model capabilities with regards to Yang modeling, right? That introduces NetConf, that introduces gRPC and GNMI type of interfaces, PSEP type of interfaces, like I mentioned already, to be able to automate that MPLS infrastructure, right? Path computation functionality across that, right? And again, the data mining, right? The data mining becomes important here, as obviously we're looking at not only being able to automate this, but then we've got to maintain and ensure those particular infrastructures are meeting the performance needs, right? So I need to look at data. There's a lot of data coming in now, but I want to put the intelligence on the device to provide that data to me, right? To provide that KPI that we're hitting. Okay? So rather than that pull type of mechanism, it's now the intelligence is there to push that utilization detail or that performance issue. Okay? Now, likewise, there's an evolution that's been happening on that vertical IT stack, right? So I know I'm showing present mode. I like to look at it as past mode of operation, but it's still present, all right? So when you look at, you know, obviously the different domains, you've got integration to each of these domains. You've got different vendor integration into each of these domains, maybe to a management system, right? Maybe direct into a particular vendor's device, right? So what does that mean? That's obviously configuration issues, high cost of OSS integration, right? There's a correlation there between all of that. So when you look at obviously some of these OSS systems that have been there, trying to put that correlation, whether from troubleshooting or fault management, it's very costly, right, to map all of this. And there's heavy errors that always come in from a configuration standpoint when looking at this current solution. What have we done? Obviously, there's been a collapse, right? You're taking that control plane awareness, right? You're taking those management capabilities. You're taking this model functionality of abstracting these interfaces and collapsing it into these domain controllers. Why? You want to abstract that interface, leveraging standards, right? Like TAPI, IETF, certain IETF standards that are there to integrate into these end-to-end service orchestrators, right? To simplify whatever that domain controller needs to focus on, right? For that end-to-end service controller, I want to be able to just say, hey, I need a path between endpoint 1 and endpoint 2, and this is my SLA, right? That should be abstracted. You let that domain controller figure out the infrastructure, figure out what it needs to maintain that performance, right? And build it out. And then what does it need to obviously maintain the reliability of that infrastructure? Okay. So what are some benefits, or to be honest, more around expectations by operators, right? For a multi-layer type of solution. All right, you can break it into these three pillars, in my opinion, right? It's simplifying the operation, right? Again, there's a pre and post side of the house, right? I want to be able to maintain, I want to be able to troubleshoot, I want to be able to do what-if type of analysis, I want to understand if I knock a particular link down, right? What services will I impact? What IP infrastructure will I impact as well, right? There needs to be that correlation there. I want to be able to have a coordinated maintenance, right, capability. What do I mean by that? Obviously, not having that awareness of what the IP infrastructure that's overriding that or going across that particular optical infrastructure, I don't know what services I will be impacting, right? First, you want to have that awareness. But second, if I do know that I'm going to have a maintenance activity, maybe I want to gracefully move those flows, right? Rather than letting fast reroute, right, or LFA reroute that infrastructure based on what it perceives as the best next hop. I'd rather have a view of what a path should be for the particular LSP, for instance, and define a maintenance, and then define, okay, here's where I will move that LSP to address the performance. Also resiliency, right? So each layer has an expectation from a performance, an expectation for resilience, right? You have high HA capabilities at each of these layers, right? But I want to be able to leverage, obviously, information at these layers, but also identify that, let's say there's a restoration event that's occurred, right? Or there's an issue that occurred in an optical link. And then leveraging maybe GMPLS, there's going to be a possible restoration that's going to happen there. Do I want to move infrastructure back that's already been moved? All right. Do I want to give it a little bit of a timer to take a look? Right? Are we going to go back into an optical infrastructure or a particular link that is having some power level issues, right? Which is then going to cause obviously the service impact again potentially, right? The other thing to look at is obviously correlation of all that information, right? Taking a look at latency information as well as shared risk group type of details at each link, at each hop, whether IP or optical. And then last but not least, right, the utilization. So looking at utilization, I want to be able to run hotter, right? I want to be able to, obviously, as things are scaling, I also want to be able to add that, right? I want to have the path computation capability to adjust, right? And being able to spread traffic across these new links or parallel links, or of course, any new link to a new spine router, right? So you need that capability to address that, right, from a computation standpoint. But you also need to deal with, obviously, certain failure scenarios as mentioned before, right? Rather than having a one-to-one redundancy, which becomes pretty costly, maybe you might want to have a one-to-n, which identify particular lag group instances, as I highlight here. And if there's a particular port, maybe taking advantage of a port or link failure, and leverage these workflow capabilities, right, based on events, such as a state change to a particular link, and then modify the particular lag group to leverage a backup type of interface to still maintain that utilization, right? As well as modifying, obviously, the optical service, right? To modify the new optical service to map it to, obviously, the optical trail that you had associated in the previous connectivity, okay? Now, so within Nokia, we've been focusing on some of these use cases, right? How do we address this, right? What are some use cases to start with, move forward, and build on, obviously, this correlation between these different layers? Obviously, this is still a starting point. There's going to be growth that's going to be happening here, as I mentioned, with a lot of this intent-based networking that's coming in, being able to define machine learning functionalities that are coming in, and the use cases that are being defined there, and how will the network learn and how will we adapt. So there's going to be a growth here, but we've started so far on this, right, on this path. And so some of them, I'm going to go through some of these, but the first one, this is the critical one in my opinion, right? This is setting the stage. Again, it's that awareness, right? It's that linkage, right? And today, many operators that are out there still have spreadsheets, right? Still have spreadsheets of IGP links that are mapped to particular optical services, and they're trying to leverage that information to look at performance on these optical links, and then hopefully then manipulate traffic engineering metrics to influence where traffic should go, right? So there's heavy spreadsheets that are out there, and this is not a tier 3, tier 2. I know there's global operators that are out there that are still maintaining it in this way, and you know who you are if you're here, right? If you have some of the type of capacity management going on today, right? But ideally, I'd like to obviously have a real-time view, right? Have a stateful view of that infrastructure, right? But the key is that correlation, that connection of that those two domains, right? And there's different ways of doing that, right? Mapping that particular client interface on the optical service to that IP interface. You can manually do that, but really you need to start taking deterministic type of approaches, right? And some of the solutions that have been there, some of the initial ones are leveraging, for instance, LLDP snooping, right? Being able to sniff, obviously, that particular LLDP transaction, going between the two different routers and identifying the two endpoints. So that way we can automatically then identify the linkage. Others could be obviously looking at packet count, right? Looking at the packet count on the IP interface, looking at the packet count on the optical client interface, and looking over a period of time to match that. It could be power levels, right? Looking at the power level of obviously the egress and the router and the ingress of a particular client interface on the optical switch, and be able to, again, match that, right? To be able to provide that. Because once you define that connection, you're basically now have correlated your information. You've correlated your layer 3 interface to that optical service. Now you now know at that optical service, here are the ODO trails, here's your DWDM service that's tied to that client interface. You now know on that IP interface what layer 3 services are associated. You know what MPLS infrastructure is leveraging that interface. So now you've tied your IP service, you've tied your MPLS infrastructure to your, obviously, client interface to that optical service, okay? So that starts the baseline for everything. Some other use cases are optically disjoint IP routing. Right? So I talked about diversity, right, and being able to look at not only obviously your IP layer and providing diversity across these IP links, but understanding diversity across the optical links as well, being able to identify these shared risk groups that these optical services are traversing, right? Being able to take that information and then influence the IP infrastructure, that IP path, right? If you're looking for diversity, complete diversity across all of these links. Okay. The other part to that is obviously an auditing capability, right? So it's one thing to obviously define an algorithm to avoid obviously these shared risk groups or shared risk links, right, for your primary and secondary paths. But then there's also the obviously these infrastructure that's already there. How do I go in and basically audit, is there diversity in a particular IP service, right? Is there diversity on these links, right? On these optical links? Do I have optical, what are the optical services that are obviously going across a particular link, right? What are the IP services that are sharing a particular resource, right? Again, understanding what's going across, that way then I can define leveraging a disjoint type of algorithm to either do node, link, disjointness, not only at the IP layer, but at also the optical layer as well. Okay. And this one I talked about moments ago, coordinated operational control, right? So obviously there's a maintenance event on a particular link, right? We want the operator to have the ability to identify what are the services, what are the IP infrastructures that are going to be going across the link, right? That's the first part. But we want to have the capability of a proactive or reactive ability to move that infrastructure, right? Not letting a particular failure all of a sudden then do, as I mentioned before, a fast reroute or an LFA of that particular infrastructure, right? Which is only going to take the next hop into account. Remember, there's SLAs defined to that path, right? There's an intent to that path. I'd rather the controller, right, in that maintenance mode setting, basically define, here's my MPLS paths that are there. I know the constraints associated with those MPLS paths. Let me compute a path and move that infrastructure now. It could be a manual or an automated approach, right? But again, I want to identify that infrastructure and then give the operator either a manual approach to move that, right, without impacting the service, or an automated way with the controller, the IP controller, to move that infrastructure across. Okay. Now, cost-effective multi-layer protection, right? This is what I was talking about, load sharing or floating ports, right, in an earlier slide. And I talked about obviously this one-to-one protection, right? You have, you've defined a particular ECMP path or a lag group, and obviously if you wanted full protection, one-to-one, you've got another interface that you define or a group of interfaces that you would define. Obviously this becomes costly. And so some solutions that we've been working on with operators is identifying a backup port, right? An optical link that's already there that can be leveraged across these different lag interfaces, right? The intent is, again, leveraging this intent-driven or workflow, event-driven capability, identify that there's a state change to a particular link. A link has gone down. Take advantage of that backup port, manipulate the particular lag member association, manipulate the optical service to now be tied to that new client interface that's tied to that backup port. Again, it's a workflow-based solution to leverage that across there. These what-if type of scenarios, right? Again, this is the start, right? But I look at this as more eventually traffic engineering, capacity planning type of scenarios. But again, it goes to these maintenance windows, right? Having an understanding, when I go into a maintenance window, right, and I want to simulate these particular failures, or I want to simulate the worst case failure, right, and the impact to that, as I look at it, any type of matrix, demand matrix capabilities, you need to have the simulation functionality, right? You need to have full awareness of all of your infrastructure on both IP and optical. You need to be able to then obviously have everything correlated together, right? But now then you could take that capability, identify a particular link, understand what are the IP infrastructures that are going to be impacted, and then be able to identify, will the controllers be able to manipulate, move that infrastructure to still meet those algorithms or policies defined for those paths. Okay. I mentioned hierarchical, right? It's not hierarchical just from a IP and optical standpoint. It's hierarchical across the same domain as well, right? There could be particular IGP domains, and there's different ways of addressing that. But with optical, you're going to have obviously different vendor domains as well. So you may have a Nokia optical domain, you may have a Fujitsu domain that's there. But the intent here is to be able to sit across that, leverage these abstract interfaces that are being defined as, for instance, an ONF and defining this transport API, right? Providing that abstract capability to create the stitching between these different domains, right? So that way you could be interfacing, these controllers could be interfacing with an NMS or a controller for each of those optical or vendor optical domains. Now, I mentioned earlier, right, as I mentioned, there's also the troubleshooting aspect of it, right? It's not just automation. You need to be able to maintain this. You need to be able to have your operators be able to troubleshoot this network. So it comes down to root cause analysis, the correlation as well. I've identified, obviously, we're focused on correlating all of this information end to end. Obviously, that's very relevant to building and maintaining and influencing the infrastructure. But at the end, I also want to have the ability, since I've got all this correlation, to provide root cause across these domains, right? Instead of just throwing something over the fence, I can't figure out why a particular LSP is down, or I'm dropping traffic on an LSP. I don't know what's impacting a particular service, right? I need the ability to understand that, the impact that we're seeing here is being caused by a particular performance issue on a lambda wavelength, right? I can then correlate that to all the interfaces that are leveraging that, to the actual LSPs, the services that are leveraging that. Narrow down that troubleshooting time, okay? Now, last but not least, right, it's this evolution path. And we've started down this path already within Nokia and trying to leverage machine learning, right? This AI, this capability of learning, right? Being able to obviously feed information, right? Being able to obviously take all this data, this large volume of information, identify patterns, right? To identify how we can address those patterns, right? As we're looking at all these events coming in, all of the utilization data. The intent there is, okay, now let's identify these patterns, right? Identify the actions that have addressed these identified patterns in the past, these situations, right? And then moving forward, identify obviously these baselines of utilization, right? Of some of the KPIs across the infrastructure. Identify then potential workflows, that closed loop type of capability and learning, having the operator still have the feedback loop there, that he can obviously make a decision based on some feedback that's provided, based on information that we learned on the topology state, performance information, right? All of this data that's coming in. Right? So this is where we're going, right? Especially as further and further, right, there's evolution in that intent-based networking, right? You're defining these intents on these infrastructure, these services. Now let's start leveraging the data that's coming in and providing that self-driving capability, right? So this is what we've started already. Our first focus was around obviously identifying patterns of issues that are going on, right? So that way we can identify to the operators, this is a similar pattern, right? That's causing a network flapping issue. So instead of looking at thousands of events, you're looking at maybe 20, 30 situations that have been identified that are meeting this particular pattern, okay? And then give the operator some choices on how they want to address it. So this is our first implementation, but then it's going to go further from there. Okay, so just to obviously kind of bring this all together a little bit, right, and looking at the benefits, our focus is obviously, and I think everyone's focus is obviously simplifying operations, right, decreasing, providing the tool sets that are there to provide that correlation across this, right, providing the interconnectivity across the service infrastructures, right, increased network utilization, right, we talked about large scale, adding more spine routers or adding more infrastructure to handle obviously the particular services and the demand that's coming in. You need to have obviously the capabilities to compute that infrastructure and maintain that, right? One thing I didn't mention is, we talk about this growth from let's say a leaf spine type of architecture, but with that you're spreading traffic across the network potentially, right? You need to be able to identify, let's say, black hole type of events. Now that you're spreading traffic across the network, how do you identify that there's an event that's occurring that's dropping traffic somewhere, that you can now address it and then avoid that particular path, right? So you need to have that stateful awareness across, you need to have topology detail, obviously you need to have utilization information as well, right, coming in. Network resiliency, as I mentioned, right? We're looking at all these different resiliency capabilities that have been introduced over both on the IP side and obviously on the optical side with GMPLS and some of the capabilities there with CDCF and in the flexibility, right? Being able to take all of that into account and be able to make your decisions, right, on that infrastructure. And then speeding up planning and processing, right? As I mentioned, these what if, these demand matrix capabilities, and looking at whether the capacity is there to handle failure scenarios or worst case failure scenarios, right? And look at predictability of how much services you can add potentially, where do you need to add potential scale, right? As well as obviously speeding up the agility of introducing these services, right? As mentioned in these presentations, the automation aspect, the modeling, the abstract modeling, right? The workflows to deliver those configurations, okay? And I think that's all that I've got. I know I've kind of gone above a little bit in the time. Are there any questions? With that, I know I'm before lunch, so thank you for the time. If obviously there's any questions, send me an email. My email information is on the slide deck as well. Okay? Thank you.